Hi everyone. Today we are going to learn how to use trigonometry to find lengths of triangles that are missing. If we look at number 1, we see that we are given that one length is 10, but this length over here going vertically is not given. It's x. We need to figure out it. And to be able to do that, let's remember what we learned last time. We remember that we had a way to remember these trig functions as SOHCAHTOA. So sine equals opposite over hypotenuse, that's the SO, and cosine equals adjacent over hypotenuse, that's the CA, and TOA is tangent equals opposite over adjacent. So SOHCAHTOA, and I'm just going to leave that up there so that I can refer to it at any time. In number 1, the angle that they have given us a value for is this 27, and I'm going to arc it, and all the sides are going to be set up in relationship to that angle. The hypotenuse is always directly across from the right angle, so I can label this as H. And remember that the angle is sandwiched in between the hypotenuse and the adjacent, so that 10 is the A. And then from the angle, the side that's farthest away is the opposite. So now our sides are labeled. Notice that I have a value given. I've got 10 for the adjacent side. I have an x given for an opposite side, and there's nothing over on this hypotenuse. So I'm not even going to use this hypotenuse at all. I can even cross it out if I want to. I'm using O's and A's, and if I look up here, sine uses O's and H's. Cosine uses A's and H's, but tangent is the one that uses O's and A's. So I am going to use tangent. So tan of whatever angle it is, in this case they gave us 27 degrees, so it's the tangent of 27 degrees equals opposite over adjacent. The opposite side, the O, is the x, and the A is the 10. So x is on top and 10 is on the bottom. Just like any normal equation, if you are solving for a variable, you want to get that variable all alone, so you do the opposite of what's happening there. This fraction line, remember, it means to divide, so you're doing the opposite, so you're going to multiply by 10 on both sides. If you do something on the right, you do that same thing on the left. And 10 divided by 10 cancels to a 1, leaving just one x right here. I don't have to write the 1, it's just x equals, and if I refer to the line before, x equals 10 times the tangent of 27, and I can put this right into my Desmos scientific calculator as 10 tan 27, and it will calculate for me. So I want to come over here and do 10, and let's see, let's go back. Okay, 10 tangent of 27, and the directions say to round to the nearest tenth. The nearest tenth is the digit right after the decimal point. So we need to look at the second digit after the decimal point to decide whether it can round up or not. The second digit after the decimal point is 9, and the rule is 5 or greater lets that digit round up. So this will be 5.1. So x equals 5.1. And that one's done. Okay, let's do another similar problem. We're talking about the angle 39 now in number 3. We want to label the sides first of all. Across from the right angle is our hypotenuse, and the angle is always sandwiched in between H's and A's. So that's our adjacent side. And the side that's farthest away is our O. Now notice we have H given the 7, and 8 is the x. We don't even have anything for the O, so we don't really need it. We're going to look in our acronym up here, SOHCAHTOA, to find out which of those trig functions uses A's and H's. And if we come on up here, we can see that cosine is the one that uses A over H. So I'm going to use cosine. And after the trig function comes the angle degree. So it's the cosine of 39. And it equals A over H. So this A is going to be on top with the x, and the h is on the bottom with the 7. So it's going to be x over 7. We're going to solve it the same way as the previous one. X is being divided by 7, so you get to multiply by 7 on both sides. 7's cancel, leaving x all alone. And you can go into your calculator and put in 7 cosine of 39. 7 times the cosine of 39 is 5.4, and the 4 afterward in the hundredths place is not enough to round up, so it really is just 5.4. Okay, great. Let's find one that might look a little bit different. I'd like to come on over to number 4 and show you that one. You start out the same way. The angle that we're talking about is 46. The hypotenuse is always directly across from the right angle, so there's h. The angle is always sandwiched between h and a, so that's a. And the 8 becomes the o. Now the side that has nothing on it is the adjacent side, so you don't really need the a. You need the trig function that uses O's and H's, and if we come on up to where we've written our acronym, SOHCAHTOA, we see that sine equals opposite over hypotenuse. Sine uses O's and H's, so that's what we're going to use. Sine, and then right after that comes our degrees, so sine of 46 equals, and we need opposite over hypotenuse. So this time the number is going to be on the top. That 8 is opposite, it's on the top. Hypotenuse is on the bottom, x is on the bottom. Now, there's a slow way to do this. You could multiply by x over here, and anything you do to the right-hand side, you want to do to the left-hand side. So we can multiply by that x on both sides. Now we still want to get x all alone. So what I have is x times the sine of 46 equals 8. Now I want x all alone, so I'm going to divide by the sine of 46. So sine, not great handwriting there, guys, but sine of 46 gets divided on both sides. So sine of 46 is on the bottom. This sine of 46 cancels that sine of 46, and you have x equals 8 divided by the sine of 46. Okay, so let's go over here to our calculator, and we're going to put it in just like this, 8 divided by the sine of 46. So here's 8, and I have to hit the divide. Actually, let's clear all first. 8 divided by the sine of 46. And that ends up giving us 11.1, and the 2 is not enough to round up, so it really is just 11.1. So x equals 11.1. Okay. Let us scroll down a little bit. And I want to show you one that's like number 4 that we just did, but this time I want to show you a way to do it faster with just a quicker algebra approach to it. Now I've lost my little acronym, so I'm going to write again here SOHCAHTOA so I can refer to it, and you can see how I decide which trig function I'm using. So SOHCAHTOA. This is in number 12, they've turned our triangle kind of upside down, but you still begin in the same way. Let's make an arc over the angle that they gave us. This 74 is the angle that they gave us. And we'll make the arrow that points from the right angle to the hypotenuse, we will label that hypotenuse, that H. And the angle is always sandwiched in between the hypotenuse and the adjacent side. So even though the triangle has turned, those rules still happen. Angle is always sandwiched between the hypotenuse and the adjacent, and the farthest away side is the opposite. Now if we look at what we have an x on the hypotenuse and a 19 on the adjacent, and we don't really have anything for the O, so we don't need it. The trig function that uses a's and h's is the c, the cosine. So cosine equals the a over the h, or the adjacent over the hypotenuse. So we're going to start with the cosine of 74, the angle degree, and it's the a over the h. That's 19 over the hypotenuse, which is x. Now number 12 is like number 4 because look, the variable is on the bottom of the fraction. And I could go through those steps that I did by multiplying both sides by x and then dividing by the cosine of 74. But if you noticed in number 4, what happened was the x and the cosine of 74, or whatever the trig function was up here, really just switched places. If you look back at number 4, the x came up here and the cosine, or the trig function, came at the bottom of the fraction. So you can do something like I like to call the old switcheroo, and you can switch that x and bring it over here on the left. Leave 19 on the top of the fraction, but bring cosine of 74 down at the bottom where the x used to be. That's just a quicker way to get that x all alone, so you can put this in the calculator. It'll still be 19 divided by the cosine of 74, just like the other one did. So we'll do that. 19 divided by cosine of 74. And that ends up being 68.9, and the 3 after the 9 isn't enough to make that round up, so it's just 68.9. So x equals 68.9. Okay, let's do another one just to help you out a little bit more. We'll start by arcing the angle we're talking about and then labeling the sides. The hypotenuse points, the right angle points to the hypotenuse, and the angle is always sandwiched in between hypotenuse and adjacent. The side farthest away is the opposite. If we look over here, we need O's and H's, but we don't need the A, so I'm just going to kind of ignore it. The trig function that uses O's and H's is sine. So sine of, and our angle is 16 degrees, equals opposite over hypotenuse. That would be the x in the O spot and the 18 in the hypotenuse spot. All right, this is like the first kind I showed you, where you need to just multiply by the number at the bottom of the fraction, both sides. 18 cancels 18, and so into the calculator you're going to put 18 sine 16. So 18 sine 16. And that's 4.9. Notice that the 6 is bigger than the 5, so 6 would make the 9 round up to a 10. You'd carry the 1, and it would be 5. This actually rounds up to 5.0. You can think of it as being like $4.96 is really close to $5. So when you round up, it will be 5. Now, the way I like to show that we've actually rounded is I won't just write a 5. I'll write 5.0, and that kind of cues me in that I've rounded. Okay. trying to look and see if there are any of them that would show you anything different or challenging. But it looks like all of the other skills are just the same as what we've just covered. So any that I didn't cover, those are yours to do independently. And feel free to email me or Skype with me if you have any problems. Have a great day.